Hello guys, we are now in vertical circular motion. Earlier you saw that in horizontal circular motion, uh, the velocity will not change. So we were looking at uniform circular motion, or an object moving in a horizontal circle. So why the velocity is not changing? Because since it is moving in horizontal circle, the height will not change, right? Height will not change. That means there will not be any change in the potential energy. Therefore, kinetic energy is consistent, and kinetic energy consistent means it has the same speed. Any question? Right. So now in a vertical circular motion, you know that the particle will change from position P to Q. When that happens, there'll be a corresponding change in height, right? Suppose this is the reference line, reference point, ref. So when the particle moves from P to Q, there will be a corresponding change in height. Now, what happens here with this? Now, in this example, we are looking at a bead moving on a smooth wire, right? Bead moving on a smooth wire. At P, it is given a velocity, a speed of U. Then it will move along the bead. It will not move away from the bead because they have been threaded onto the bead. And at a point like this, point Q, you know that you have to mark the weight. This is the internal force, mg, weight. And due to the contact of the bead with the wire, there will be a reaction force. So reaction force will be perpendicular to the bead. Now we can use the conservation of energy here because this reaction, this external force will not influence the motion. So this is acting perpendicular to the V, perpendicular to the speed. Therefore, it will not change, it will not influence the speed. This resistance or the contact force will not influence the velocity or the speed. Therefore, we can use the energy conservation law. So a change in height will result in what? A change in height will result in a change in potential energy. A change in P dot E. It will result in a potential change. Okay. So a change in potential energy. So due to this, a change in potential energy will result in a change in kinetic energy. K dot E. Right? It will result in a change in kinetic energy. A change in kinetic energy, then since there's a change in kinetic energy, you know that the mass will not change. Therefore, the speed of the particle will change. Change in speed. Right. So a change in speed will be there. So that's why I have mentioned U here and V here, V there. So due to this change, certain things will happen. You know that the now we can find what V is based on these data present. So what is V? We can use conservation of energy. So starting energy would be half mu squared. This is equal to half the kinetic energy there, mv squared plus mg delta h, change in length, change in height. Now this is r, this is r, this is theta. So change in height can be obtained by, so delta change, delta h is equal to r, this length over here, r minus r cos theta, this small length, r cos theta. So this is equal to r1 minus cos theta. Right. So we can find an equation for V from this. So V squared is equal to U squared minus 2 mg delta H. So U squared minus 2 mg delta H can be replaced by R1 minus cos theta. So this is an expression for V squared. Right. Now, so what causes the motion of this bead in the wire? So there has to be some forces acting towards the center, right? So we can apply F equal ma towards the center, right? In that case, so the force towards this would be R minus mg cos theta is equal to m. What is the centripetal acceleration? So V is given at this point. The speed is V. Therefore, V squared over R. Right. So what is R then? R is equal to m. We can factor out an m from this. Then this becomes G cos theta plus V squared over R. Right. So this is an expression for R. So we can calculate the reaction on the bead by using this expression. Now we can replace V squared with this expression given. Then R is equal to m G cos theta plus, so V squared over R, this is V squared. So you have to divide this by R, then you get U squared over R minus 2 mg plus 2 mg cos theta. So I have already expanded this here. So R is equal to m g cos theta plus 2 mg cos theta. That means m is not there. Yeah, sorry about this. M is not there. 2g cos theta, 2g cos theta and g cos theta is 3g cos theta. So U squared over R. This is 3g cos theta minus 2g. You can also factor out an g from this expression. Then R equals mg U squared over Rg plus 3 cos theta minus 2. Now this is an expression for R. Right. So we have arrived at this answer based on this example here, a bead traveling on a circular wire. So depending on the example, the centripetal forces will differ. So we can have to find centripetal forces. Now, in this example, this bead is moving on the circular wire. It cannot go away from this circular wire. It has to stick to this circular path. And another example would be a bead or a particle tied to a fixed point by a rod, right? Tied to a fixed point by a rod. Then when it is given a velocity, it will move in a circular path or partly in a circular path. Now, what happens if instead of a rod, if it is a string, then there can be a chance where it will move away from the circular path because there are no restrictions. There are more freedom than these two examples. So depending on the example, we will see how to arrive at certain answers. Right. So this is about vertical circular motion. It's a basic. So what you have to do is you can use conservation of energy, and also you can use F equal ma towards the center. So using these two relationships, we can arrive at certain answers. Right. So thank you for watching. We'll see you again in a next video.